Okay, so here we go. Today is 13th, 4/13. And today, again, we're talking about polynomials. Remember, polynomials are all those crazy little x cubes, x squareds, x fours. They have those curvy graphs. But specifically, we're talking about factors, whether something's a factor or not, okay? So today, we talk about synthetic substitution. Different than subdivision. Division is that upside down dividing, right? That's the synthetic division. But today's substitution is just to plug in the number. And if we get an answer of 0, we know the divisor is a factor because it goes in even, right? Remainder is 0. Good. So all we do is plug it in and we can find out what the remainder is. We don't have to divide it. We just plug it in, we get the remainder, okay? We don't get the answer, but we get the remainder. What's the big deal? Well, if the remainder is 0, right, it's a factor, okay? So today, let's take a look at some of that. So let's walk ourselves through today's lesson. So right off the bat again, our Common Core, we're talking about polynomials and factors, okay? So mostly, we'll talk about factors of polynomials, okay? All right. So example 1. Before we do anything, this particular problem we're going to see 3 different ways. And I want you to see it in 3 different ways because it's going to just hammer home the whole thing of being a factor, okay? So right off the bat, x minus 3 is a factor of what do we get here? Because this times this will get us something, right? So x minus 3 and x squared minus 2x minus 8, both of them are going to be factors of what we get. Does that make sense? Because this times this will get us what we get. So these two will be factors. So let's multiply it out. X cubed minus 2x squared minus 8x, right? Minus 3x squared plus 6x plus 24. How am I doing? I went x times all 3 of those. I went negative 3 times all 3 of those, okay? Now let's add them up, line them up, and I should get an answer of x cubed minus 5x squared minus 8x plus 24, okay? Now, here's the big deal that I care about. X minus 3 is a factor of this, and x squared minus 2x minus 8 is a factor of this. You guys agree with that? Yes, Rena. Oh my goodness, it is a minus 2x. Thanks, I don't want to make a dumb mistake, so we said positive 4. Thanks, you guys. Darn me, I do make mistakes, don't I? Yep, I wish I was perfect, but I don't think that'd be very good either. No. So, here's my polynomial. So, x minus 3 is a factor. Yes. Can I make another mistake?
Minus 8 plus 6.
Hold on. X cubed minus 2x squared minus, it is minus 8x there, but then that, minus 3x squared, positive 6x, so that's going to be a minus 2x. Is that what you're saying?
Yeah.
Darn me. That's another. Okay, x cubed. Thanks, Josie. Minus 2x. How am I doing now? Better?
Better.
I'm better. Okay, now, there we go. So, let's divide p of x. Let's divide this. X cubed minus 5x squared minus 2x plus 24 by x minus 3. So, synthetic division, right? So, let's go 1, negative 5, negative 2, 24, remainder, and I'll put 3 here. Okay, remember it's the opposite, right? It's the opposite of that. It's got to be the opposite. So instead of negative 3, it's a positive, okay? Now, I already know the remainder is going to be 0. I already know the remainder is going to be 0. And I also already know the answer is going to be x squared minus 2x minus 8. I know that, but I want to prove it, okay? Because I know I just multiplied it times x squared minus 2x minus 8 and made the polynomial. Provided I didn't make any dumb mistakes, right, Josie? It should work, right? So let's do synthetic division. Bring down the 1. 1 times 3 is 3. Add them, and I get a negative 2. Multiply, and I get a negative 6. Add them, I get a negative 8. Multiply, and I get a negative 24, and I get a 0 remainder. I knew it was going to be a 0 remainder because I already knew it was a factor. I already knew it was a factor because I made it with that, right? I also already knew that the answer was going to be I also already knew the answer was going to be this, okay? I already knew the answer was going to be 1x squared minus 2x minus 8. So why did I do it? Just to hammer the point home that if it is a factor, you will have a remainder of 0, right? I also made the point that because this times this equals this, then the factors of x cubed minus 5x squared minus 2x plus 24, the factors of this are these two terms, right? Now, let's keep going on. So let's find p of 3. Now, p of 3 should be 0. P of 3 should be 0. Because if you have x minus 3 equals 0, and you solve for 3, if we plug in 3 into my polynomial here, I will get 0. I know I'm going to get 0 because I know it's a factor. So let's do it. So I'm going to go p of 3 is going to be, let's see, it's going to be a 3 cubed minus 5 times 3 squared minus 2 times 3 plus 24. I'll use my calculator, and I already know the answer's got to be 0. It's got to be 0 because we know it's a factor, right? Okay, this is a synthetic substitution piece, all right? So if I go 3 to the third minus 5 times 3 squared is minus 2 times 3 plus 24, 0. I knew that it was going to be 0 because I knew it was a factor. It has a remainder of 0. It's going to be a factor. So p of 3 is 0. I knew that, okay? Now what about p of 4? What about p of 4? Yeah, I'm going to squeeze it down here because I'm running out of room. So I'm going to go p of 4. Let's see what that's going to be. So that's going to be, of course, I'm plugging them back into this. I'm plugging them all into this because it's my polynomial. So I'm going to go, all right, 4 cubed minus 5 times 4 squared minus 2 times 4 plus 24, right? Let's find out what that answer is. Plug that in. 4 cubed minus 5 times 4 squared minus 2 times 4 plus 24. Boom, I got 0. Oh, I have another factor. So that means that remainder of 0, p of 4 is 0. I've got another factor. Wow, I didn't see that one coming. Well, yeah, I kind of did, but you know, that's the way I teach, huh? So I got another factor. So that means x minus 4, that means, you ready? That means x minus 4 is a factor. Opposite, remember? X minus, that's a factor also. How about negative 2? Let's try that one. P of negative 2, let's plug that in. So I'm going to go and plug it into the original. I'm going to go negative 2 cubed minus 5 times negative 2 squared minus 2 times negative 2 plus 24. Let's see what happens here. Okay, so if I did my parentheses, negative 2 to the third minus 5 times negative 2 squared minus 2 times negative 2 plus 24, 0. Boom, I got another factor. So I got another factor because p of negative 2 is also 0. So that means x plus 2 would have been a factor. Now wait a minute, you know something I recognize just because I'm a crazy math teacher, right? I looked at this early on and my brain said, wait a minute, doesn't that factor? What would that factor into? Just this. What would x squared minus 2x minus 8 factor into? Anybody know? X minus 4, x plus 2. Oh, am I going to have an aha moment? Here, you guys want to see my aha moment? And so it has 3 factors. So this polynomial here has 3 factors. It is going to be x minus 3 is one factor, x minus 4, and x plus 2, which means this polynomial could have been written, I know, not as exciting as I am. You guys are probably like, okay, whatever, Mr. Davies. This thing could have been factored into an x minus 3 and an x minus 4 and an x plus 2. And if I were to FOIL and multiply it all the way out, I would get this. Question, Avi.
I have no idea what you're saying.
Okay, so glad you asked, okay? So if I can plug in a number and get a 0, it's a factor. What does that mean? What does that mean? Okay, so if I have x equals 3, right? it came originally from an x minus 3 equals 0. You with me on that? Okay, if x equals 3 and I plug in 3, right, it came from an x minus 3 equals 0. So if I solve for it, I get x equals 3. You got it? If x equals 4, then I would have got it from an x minus 4 equals 0, right? You okay on that? Follow me, okay?
Oh, okay, yeah.
Okay, so that means this, and that all are factors, which means to be a factor, just plain old like middle school math, there's like this times this equals that. Like, okay, take 24, right? Like 24 would be 6, 4, and so we can go 2, 3, and 4. 2 times 3 times 4 is 24. Those are all factors, right? And these are x's, right? Blah, blah, x's, but this times this times this times this times this, all three of these together will make this what it's look like. That's their factors. Because they're all three numbers that multiply to make that number. Now, it doesn't look like a number, does it? It looks like a bunch of Chinese x's, y's, but that's a number, okay? And these are the factors. So this number times this number times this number makes that big number, okay? How do I know the factors? Because when I plugged them in, we got 0. No remainder. No remainder, right? Okay? All right, let me keep going. So now, example 3. Okay? Is 3 a factor? Now, there's two ways you can do this. Now, Avi, you don't like to factor, right? So, all you got to do is plug it in. If you plug it in and you get 0, it's a factor. If you plug it in and it's not 0, it's not a factor. Does that make sense? So let's plug it in. So let's plug in 3. Okay, so if I go f of 3, and I go 3 squared plus 2 times 3 minus 3. Okay, so let's plug it in. Clear. 3 squared plus 6 minus 3, I get 12. So it is not, so x equals 3 is not a factor. And 80, good deal. We didn't have to factor. But we know it's not a factor because it didn't equal 0, right? It equaled 12, equaled 12. It's not 0. Okay, now what about the 1?
Wait,
Yeah.
by x equals 3, does that just mean f of 3 equals 3?
So it's like x equals 3, yeah, which means it came from x minus 3 equals 0. So
Okay,
if I,
so from that expression you got x equals 3.
yes. Okay, let's check 1. So f of 1 is equal to 1 squared plus 2 times 1 minus 3. That equals 0. So what does that tell you? I got 0. What does that tell you? It's a factor. So we know, nice job, Angel. We know that 1 is a factor. Does that make sense? How do you get 1? So if x equals, now watch this. If x equals 1 is a factor, that came from x minus 1, didn't we? So x minus 1 is a factor. Which means when we factor this, x minus 1 should be in there. When I factor this, x minus 1 should be in there. Well, let's factor it. What the heck? What is x squared plus 2x minus 3? What does it factor into? I already know that one. It's got to be an x minus 1, right? Because we just showed it. And then it's got to be the x plus 3. Oh, I might have made a mistake there. 9, 6 minus 3. I don't know. Anyway, turn the page. No, not yet. Not yet. Ah, it's negative 3. Of course, it's right. Didn't make a mistake. All right, 80. Sorry to ruin your world, but when I turn the paper, we're going to factor. Okay. Factor.
Does it factor?
It does factor. It does factor. Okay. So what do you think? Anybody have any ideas on how to factor this one? Oh, wait, no, we just did, didn't we? We just did. Let's do it again, huh? So let's factor this one. What's it factor into? You know you've got to start with x and x, right? What are the multiples of 3? What times what makes 3? And we need a positive 2. So what are we going to use? Positive 3 negative 1. Amy, okay? Okay, all right. Time we're done, you're going to say, I can factor, Mr. Davies. Okay. Okay, what about example 6? Factor, factor, right? Okay, what do you think? X and X, right? Yes, say it, smart girl.
-3 and +3.
Yes. And you can even double check your, you can even check your double smiley, can't you, Alyssa? So if you check your double smiley, you get, so if you check your double smiley, you get 0, don't you? Because there is no middle term. It actually makes sense. Do you double smiley?
Oh.
3x, negative 3x makes 0. And of course that makes sense because there is no middle term, right? So believe it or not, math is about the only subject that makes sense, okay? That's the problem. Makes sense. So now what about this one? What do you think? What do you think? Take a stab at it, huh?
I was going to say 9 and
9 x squared.
So I heard x squared,
Okay, yeah.
right?
That's how you get
Negative 9 and
Yeah.
positive 9.
Okay, good. Yes. Or the other way, right? Either way. But I'm going to factor one of these two again. In fact, maybe I'll have Anna show me how to factor this again. Oh, you don't get the 3. I'm ahead of myself. I'm ahead of myself. I got distracted. Okay. So I can factor one of these again. I'm going to factor this one. This one here can be factored again. What do you think that one's going to be? X plus 3, x minus 3. This one cannot be factored again. This one cannot be factored again. Okay, try it. If you think it's x plus 3, right? Wouldn't you think it was x plus 3? So this one, can it be factored again? I mean, I'm thinking, yeah, sure, why not? Why not, you know, x plus 3, right? But the problem is with the double smiley, what happens with the double smiley?
3x, 2x, and 6x.
And there is no 6x, is it? So this one cannot be factored. Cannot be factored. But this one can.
Would you want us to factor it again on a test, Mr. Davies, or would you take it like the first way?
I will want you to factor it again. I wouldn't mark it completely wrong. I
But
would
maybe
just
like half a point.
take
or
half a
something.
point off.
Okay.
If you didn't go all the way, just take out, okay?
How worth is it?
Now,
How worth it is it for me?
number 7. Okay. Everybody watch. 4 terms, group them. 4 terms, group them. 4 terms, what are we going to do? One more time. 4 terms, what do we do?
Group them!
So how do we group them? Well, we put these 2 in one group. And we put these 2 in one group. Okay, we group them. 4 terms. So 4 terms, we're going to do grouping. So we group them up. The first 2 are in a group, the second 2 is a group. Okay, so now, let's common factor. Common factor. Okay, so within the first group, what do these 2 terms have in common? What do these 2 terms have in common? They have an x, but they have more than just an x. They have an x squared in common. Okay, so they do have an x squared in common, right? So out of these 2, if you pulled out the x squared, with the first term, what's left over? What's x, and if I take out the x squared in the second term, what's left over? Negative 2. Okay, now, in the second group, what do they have in common? They got a 9. Let's take out a negative 9. Let's take it and make it a negative 9. So if I pull a negative 9 out of this first term, what's left over?
X minus.
You're ahead of me, yes. X, right? And then take a negative 2 out of this. Negative 2, okay? Good, 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 good. Now, but then we can do it again, right? So we can factor again. So one more time. So again, what do they have in common? They have a parentheses x minus 2. Okay? Now, if I pull out the x minus 2 out of both, well, I like to just cross out so it does not confuse you. I'm only going to pull it out once. Does that make sense? When I pull it out for both. Does that make sense? So what's left over? Okay, not too bad. Anybody see anything else? There you go. We can factor this one again, can't we? How about one more time? And how about again? So x minus 2. Angel said, how about an x plus 3? X minus 3. Nice job, Angel. Do you agree with what he did? 9.
X squared minus.
I don't see the 4.
There's no
X
y.
squared minus 9.
Okay, never
Yeah, it looks like, maybe it looks like a 4, but it's a 9, right? Yeah. Okay, how about the number, how about the last one? Example 8, okay? 4 terms, what are we going to do? 4 terms, we're going to group. So let's put these 2 together in a group and these 2 together in a group, right? Okay, nice, okay. So, what do these 2 have in common?
X squared.
X squared. Okay. So, out of the first term, if I take out an x squared, what's left over? 2x, good. 2x is right. If I take out the x squared, it's 2x. If I take out the x squared out of here, there's really nothing left, but there's technically a 1x squared. We don't really write the 1 very often, you agree? But there is a 1 there, so when we take it out, we got a 1 left over, okay? All right with 1? Now, what about these 2? What do they have in common? A 4. So we take out a 4. What's left inside?
2x.
2x plus 1. Okay, let's do it again. Let's do it again. So now, one more time, let's do it again. What can we do next? Let's do it again. Okay, they have a 2x plus 1 in common, and I like to cross them off so I know that they've been pulled out, and what's left over? X squared plus 4. Do you see what's left over is the x squared plus 4. Now, don't factor this again. Why not? You'd think it was x plus 2, wouldn't you? You'd think, okay, man, it's got to be x plus 2, x plus 2, but let's do our double smiley. What do you get with the double smiley? Do you have a 4x in here? This can't be factored. So what you're going to find, it's called difference of squares. When you got a square minus a square, you can factor it. When you have a square minus a square, you can factor it. But if it's a square plus a square, it does not factor. So if it's a plus here, you cannot factor, okay? All right, 1 through 9, that's it. And then I also want you to do this problem right here, 2x plus 3y to the 4th power, okay? That's it, okay? Not too bad. And the homework's not bad either. You should get it done. You should get it done in plenty of time, and then I know